So for our demonstration, what we have set up here is a couple different Cycle Gard units on a manifold system. We have a leg in this manifold that's going to show standard cycling of a pump without a Cycle Gard. We have our C152 unit, direct acting inline adjustable unit. Down below, we have our C153 stainless steel unit, which is intended to be used in the well with an in the well tank. And last but not least, we have our Cycle Gard 4 CB152 SST, another inline direct acting adjustable unit that is used as a tank T package. Beneath me under the floor is a large tank of water. In that tank, we've got a submersible pump. Comes up through the left side of the manifold here. All this valving I know looks confusing, but it's so we can bypass and shut off certain valves and run certain legs. We are set up to run as a standard system with a 40-60 switch, about a 1.5 gallon tank, pressure relief valve, boiler drain, pressure gauge, all that you would see in a standard residential application. So I'm going to allow flow right now, and then we're going to watch this pressure gauge right here, and we're going to see what happens as the pump cycles on and off. So pressure's dropping. Once that pressure gauge hits about 40, the switch is going to engage, turn the pump on. Pump is now running. It hit 60, it shut off. So it's going to drop to 40, kick back on again. I don't know, maybe a 10-second cycle time, something like that. With the rapid starting and stopping of the pump with this small of a tank, that is bad for our pump. That is bad for our motor. So we want to eliminate that. One way of doing that is with a Cycle Gard. When this builds up to 60, I'm going to shut the valve off. And now I'm going to switch over to our first Cycle Gard unit. Now what's going to happen this time around, pressure is going to drop to the 40 PSI setting of our switch. The pump is going to kick on, and this Cycle Gard is set for 50 PSI. Once the pressure at the Cycle Gard hits 50, that's all that Cycle Gard is going to let through it. So our system is going to stay constant at 50 PSI as long as there is demand on the system. So our pump just started. You'll notice the pressure build to approximately 50 PSI, and it's going to stay steady. Our pump is now not starting and stopping. This is going to protect the pump. Electric motors like to run. They don't like to start and stop. So it's going to keep us within our recommended starts per motor manufacturer, lower our amp draw on the pump itself, on the motor itself, and it's going to allow a nice steady system pressure of 50 PSI. We may see a drop in the pressure here from our 50 PSI. Direct acting valves have what's called a fall off, or similar to a head loss. The higher the flow that we are trying to put through this valve will impact the pressure here. So this will need to be taken into consideration when commissioning the system for the first time, dependent upon the size of our tank, the settings on our pressure switch, and the constant pressure required in the household. We need to keep in mind the starts and stops on the motor. So there is going to be some fine tuning of these valves when they are first installed to satisfy the demands of the home. So you'll notice if I allow more flow through this valve, meaning maybe a sprinkler system went on or multiple points of use in the home, you'll notice the pressure drops some on our switch. Again, that's a function of the fall off of the valve. Notice the pump's been running nonstop. It has not shut off. It will shut off once and only once the downstream demand stops. We're going to build to 50 PSI, and then the internal bypass on this Cycle Gard will allow the pressure to build up to our 60 PSI and shut the pump off. Now I'm going to switch over to our C153. Again, intended for in the well service with an in the well tank. That is located down here. These valves are not adjustable, so they must be ordered from the factory at the desired setting. We offer them in 40 PSI, 50 PSI, 60 PSI, and also 70 PSI. The most common one is going to be your 50 PSI. Running in second place is probably 60 PSI. But again, upon initial commissioning, there are a lot of things that need to be considered dependent upon tank size and the pressure of the non-adjustable Cycle Gard. So let me make sure I have the correct valves open. I do, and we will run it again. So our pump just kicked on, and you'll notice 50 PSI. Okay, so again, the C153 intended for in-the-well service with an in-the-well tank, non-adjustable, is going to perform the same as the other ones that we're showing you. However, we cannot make adjustments. So this has to be ordered from the factory with the desired pressure of your system. It is important to point out with this model that on the underside of the flange, or what would be the pump side of the flange, there is a weep hole machined into the valve body. That weep hole is to prevent the valve from hydrolocking over time. It will not leak constantly, but the potential does exist. That is why we want this valve in the well with the tank. I do not want a C153 located in a basement. Last but not least is our Cycle Gard 4, our stainless steel version. You'll notice we have this set up. There's a separate pressure switch here. That's because this is a mini tank T package. So the valve body is machined with taps to install your pressure switch, your pressure gauge, pressure relief valve right in the valve body. It is important, that being said, that we install these valves properly in the direction of the flow arrow, okay? That same holds true with all of the valves that we're showing, but particularly with this one because of the way it's set up and where our taps are. So now we're utilizing this lower pressure tank, same size as our upper pressure tank, but this is a totally separate system for small workspaces, maybe a closet, maybe a trailer, maybe a hunting camp where there's small space, tight space, and we just cannot accommodate larger tanks. So here we go. Now this Cycle Gard is set up exactly the same as the bronze one, set at 50 PSI. Pump is on, pump is running, and this is gonna run nonstop until there's no more demand on the system. It's gonna hold right up. Pressure dropped a little bit, but our pump is still running. Again, going to keep a nice even amp draw on your pump, keep things nice and consistent downstream. The only time there may be an issue is if our usage exceeds the output of our pump. Other than that, these valves are very robust. Biggest culprits you might encounter would be mineral buildup, sand, maybe some pipe dope upon initial install. So it's very important to try to keep debris to a minimum. If there's a very sandy well, you may want to have a filter in line. And just use caution when installing them that we're not getting, again, pipe dope, thread sealant, something like that in the valve. If there is some problem, that the adjustable units can be maintained. If the system is depressurized, they can be disassembled. The internal cartridge assemblies can be replaced, repaired, very easy to inspect. Reference your installation manual. There's directions there how these valves can be disassembled and reassembled. We offer repair parts. So very simple, very basic. I had referenced how upon install, it's very important to make sure things are set correctly. With our larger units that we don't show in this working demonstration, it is also important to take into consideration your tank size, your switch settings, your pressure relief settings. They will require larger tanks. If we have a larger, let's say 2-inch Cycle Gard CI squared, used maybe in a very large home, a restaurant, maybe it's being used for irrigation, it will be necessary to have a larger tank. Something of that nature with a high pump output is going to require a larger tank. Again, reference your installation manuals. If there's ever any doubt, call the factory. We're happy to discuss with you. Very basic, but there are some intricacies to doing the install and doing the setup so that these valves will last you for a long, long time.